Okay, so as in the last video we have discussed about the potential gradient. What it was the moving rate of the charge of potential per unit distance is what we call the potential gradient, and the formula of potential gradient was del V upon del R, and there we got the unit of the potential gradient as well, and that was of course volt per meter, and volt per meter was also a unit of electric field, right? In today's video we are going to learn about the electric dipole. What is that? Initially we will be discussing about the definition of electric dipole. I'll guys make you understand by the help of diagram. In tomorrow's video or in the next video we are gonna talk about the SI unit of it, and the units, other units of electric dipole and other systems of unit, right? So today we are going to discuss about the electric dipole. Electric dipole, and of course this topic is very important in terms of MCQs. All right, multiple choice questions. Let me highlight this topic, electric dipole. So initially let me tell you the definition of it, what it is, then I'm going to explain you the definition by the help of diagram. Initially let me write the definition here. So a simple system of electromagnetism or electromagnetic, in which a pair of charges or a pair of magnitude of opposite charges are placed at a distance d from each other charge, right? From each other is what we call the electric dipole. Is called, of course, electric dipole. Electric dipole, right? So what is electric dipole? Now let me make you guys understand the definition first, then we're gonna go towards our diagram. So it is a simple system of electromagnetism. It is nothing but it is simple system of electromagnetism in which a pair of magnitude of opposite charges, which means in this system, in the simple system of electromagnet, we will be having two charges and those charges will be opposite, right? Which means the one charge we'll be having will be of positive and another will be negative, and they will be placed at a distance from each other, which means there will be distance between the two opposite pair of charges. There will be pair of charges and those two charges will be opposite, means one positive and one negative, and of course there will be distance, they will be placed at a distance, is what we call the electric dipole. So now I am just going to tell you this by the help of diagram, right? What I have told you guys, it is a system of, or it is a simple system of electromagnetic in which two pair of charges are used, which means one charge I have here and second charge is here. Two pair of charges are used and that two are opposite, which means this must be positive charge and this must be negative charge. because two opposite pair of charges, and they are placed at a distance. They are placed at a distance d. All right. So this is the distance, right? So this is basically their center point. This is their center point. This distance is called L, and this distance is called L, right? So this whole distance will be equal to 2L, right? It will be equal to 2L. So this is the diagram. It is a simple system of electromagnetism in which a pair of charge, which means we have used two charges, and that two are opposite, which means one is positive and other is negative. So of course we have used one positive and another is negative. They both are placed at a distance from each other. Now see, there is a distance between these two charges, right? There is a distance between these two charges. So yes, we have placed these two opposite pair of charges at a distance. And of course if we have this center point, this is L, this is another L, so the final distance or the total distance between these two opposite pair of charges would be 2L. we'll be adding LL, right? So this is what we call the electric dipole. Isn't it easy? Of course it is very easy. It's so easy, right? It is a simple system of electromagnetic in which two pair of opposite charges are placed at a distance from each other. Then this is what we call the electric dipole. Now if I do write the formula of it, what it would be? It is of course, now this is the representation of electric dipole. Electric dipole is represented by what? It is represented by P, right? It is a representation of electric dipole, is equal to charges, the magnitude of opposite charges, which means those two charges are multiplied. I'm not going to take here two charges, however those two charges are multiplied. We need to take the magnitude of the charges, which means only Q into, now see, they are placed at a distance, which means 2L, and instead of 2L I know that what it is, this entire or this total is the distance. So of course this is equal to Q into displacement, right? This is the final formula of the electric dipole. And let me tell you, electric dipole is the vector quantity. It is a vector quantity. It is a vector quantity. Alright. So what we have discussed today is the definition of the electric dipole, what it is. It is basically a simple system of electromagnetic in which two pair of opposite charges are placed at a distance d from each other, is what we call the electric dipole. And we have made the diagram as well. We know that we are using two opposite pair of charges, which means one q1 and one negative charge, right? And they are placed at a distance, which means the distance between these two charges is what? It is d, of course. So the formula we get is P, which is the denotation of the electric dipole, is equal to Q charges. We know that it is the magnitude of the opposite charges. Magnitude of the opposite charges will mean Q into, then we have of course 2L, right? Because L plus L is 2L, and instead of writing this 2L I can write this. This is total displacement. Total displacement between two opposite pair of charge, or total displacement between opposite pair of charges. Opposite pair of charge. Alright, so the final formula we get is P is equal to Q cross displacement. This is the final formula of what? Of electric dipole, of course. Electric dipole. And then I told you it is a vector quantity since we have a cross between the two quantities, right? And there I'll be telling you why is this vector quantity, all right? But yeah, it is a vector quantity as I have written here. Let me highlight this. So this is a vector quantity. In next video we're gonna drive the unit for the electric dipole, and we're gonna see other units of electric dipole in other systems of unit. This was all for today.